Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. E2 reaction rate depends on I, the leaving group ability, 2, the base strength nucleophilicity, and 3, the substrate structure, degree of substitution and orbital overlap antiperiplanar geometry. Pair 1 versus 2, leaving group reaction. 1 uses an alkyl chloride, Cl leaving group, while reaction 2 uses an alkyl iodide, I leaving group. I is a much better leaving group than Cl because Ci bond is weaker and iodide is more stable as a leaving group. Therefore, reaction 2 has a greater rate constant than reaction 1. Pair 3 versus 4, base nucleophile both involve 2-bromopropane as the substrate. Reaction 3 uses CH3O methoxide and reaction 4 uses CH3S methanethylate. For E2 a stronger base gives a faster rate. Methoxide CH3O- is a stronger base than methanethylate CH3S- because oxygen is more electronegative and holds negative charge less stably than sulfur. Sulfur is larger, more polarizable, and better at stabilizing negative charge, making it a weaker base. Therefore, methoxide is a stronger base, and reaction 3 has the greater rate constant. So from pair 3/4, reaction 3 is faster. Pair 5 versus 6, substrate structure reaction 5 involves a substrate where bromine is on a nonbenzylic secondary carbon, the beta carbon to the phenyl group, while reaction 6 involves bromine directly on the benzylic carbon. For E2 elimination, the transition state is stabilized when the developing double bond is conjugated with the phenyl ring. In reaction 5, elimination would form a double bond between the benzylic carbon and the adjacent carbon, giving a styrene-type product conjugated with phenyl, whereas in reaction 6, with Br at the benzylic position, elimination would also give a styrene-type product. Re-examining, in reaction 5, the substrate is PHCH2CH, Br, CH3, elimination of HBr gives PHCH is equal to CHCH3, conjugated, stabilized. In reaction 6, the substrate is PHCH, Br, CH to CH3, elimination gives PHCH is equal to CHCH3 or PHC is equal to CH2-. Actually in 5, the Br is not at benzylic position, so the antiperiplanar arrangement and transition state stabilization differ. The key point, reaction 5 has Br on a secondary carbon beta to phenyl. The transition state for E2 is stabilized by partial conjugation with the phenyl ring as the double bond forms. Reaction 6 has Br at the benzylic position. While benzylic CBr bonds are weaker, the E2 transition state leading away from phenyl is less stabilized. Overall, reaction 5 proceeds faster due to better transition state stabilization through conjugation. Therefore, reaction 5 has the greater rate constant. Summary: the reactions with greater rate constants are 2, 3, and 5, corresponding to answer choice C. Why other options fail? A. 2, 4, 6, incorrect because 3 is faster than 4 and 5 is faster than 6. B. 1, 3, 5, incorrect because 2 is faster than 1 due to better leaving group. D. 2, 4, 5, incorrect because 3 is faster than 4 since methoxide is a stronger base than methanethylate. Therefore, the correct answer is C. Therefore, the correct answer is option C.